In this section, I want to give you a very simple example about VRFLite. And first I want to configure VRFLite and then talk about the theories of VRFLite. That's because this is easier to understand what VRFLite is. So for this I go for example 7200 series and add it here. And I need 4 different interfaces on this router, so I go to configuration. Here you can see that I have only 1 slot with 2 fast Ethernet. I want 2 more fast Ethernet interfaces, so here is this 2 FEs and click on OK. Now I need to have VPCS. This is a very simple thing here. PC1, PC2, PC3 and PC4, and now the connections 00 to PC1, 01 to PC2, 10 to PC3, and 11 to PC4. Now I'm going to move them so I do not care about the beauty of this topology. What I'm going to do is to start router 1, and I click on this, start all devices, right click on router 1 and go for console. I want to open console for each PC2, so let's go to PC1 console, PC2 console, PC3 console, and PC4 console. Okay, so router 1 is up in a minute. Show IP interfaces in brief tells me that I have 4 fast Ethernet interfaces. On interface fast 00, I have IP address of 10.10.1.1, for example, 255.255.255.0. No shot. Interface fast 01, IP address is going to be 10.10.2.1. No shot. Interface fast 11, fast 10 is going to be 10.10.3.1. No shot. And interface fast 11 is 10.10.4.1, and no shot. Now I will check my interfaces to see if everything is there. Show IP interface in brief. That's it. Let's go to PCs. And VPCS is very easy to configure. If I type a question mark, you can see that. If I want to know about, for example, IP address, and I type IP and then a question mark, and this gives me a very nice example of configuring IP address here. And I type IP 10.10.1.11 space /24 space and 10.10.1.1 as a default gateway. Hit enter. This is the IP address configuration on VPCS. That's very easy to work. So here is going to be 10.10.2.12 /24 10.10.2.1. This is gonna be IP 10.10.3.13 /24 10.10.3.1, and on PC4 IP is going to be 10.10.4.14 /24 10.10.4.1. Hit enter. Now if I go to my router, check my routing table, it tells me that I have all of these networks, and I know about the 32-bit IP addresses that are my hosts here, connected directly to me. Now, I want to show you something interesting. If I go to PC1, I should be able to ping 10, 10, 12, 2, 12 That's because there's a router in between. Everything is working just fine. So I need to be able to ping 313. Let me interrupt it. And 414. You can see that all pings are successful. That's because there's a router in between and I can connect to other PCs. But what if I change my policy? For some reason, I want PC1 only to talk to PC2, and I want PC3 to only talk to PC4. I do not want these PCs to talk these PCs. How can I achieve this goal? You may say, I need to go for MPLS. That's quite correct. MPLS is a very good one. But on one router, configuring all those commands is kind of, a drag. I do not want to go for all those complications configuring MPLS. I want a much simpler way to configure this. So VRFLite is what we go for. Now, how can I configure VRFLite? You can go to router 1 and check your routing table. You can see that these PCs can talk to each other because they check because router 1 checks its routing table and sees that there is a route in its routing table for the destination. What if I do not have a route for the destination in this routing table? If I remove some routes from this routing table, then other PCs cannot talk to each other. How can I do that? Actually, what I do is I create some more routing tables and put some of these routes into that routing table. This is what is VRF. A VRF, let me write it here. A VRF actually is virtual routing and forwarding. This is exactly what I do. This is my global routing table, okay? It doesn't have a name. Every route goes here if I do not specify any other routing table. But here, I have another routing table, and I may have another routing table here. So, this one is the global one. If I do not specify a routing table, the routes go here. But this one has a name. For example, this one is NY. This one is LA. Doesn't matter what the name is. I'm just putting a name on these routing tables. So I take the routes from global routing table and put them in these. For example, I go for 10.10.10/24 here, 10.10.20/24 here, but I put 10.10.30/24 here and 10.10.40/24 here. You can see that these are in different routing tables. So if I try to connect from 10.10.1 to 10.10.3, this is not possible. That's because that's in another routing table and I have no access to that routing table. So how can I do that? How can I achieve this goal? I need to create these routing tables first. Then I need to tell these routes that they belong to this routing table. This is achieved using what is called a route distinguisher or an RD. A route distinguisher is just a number. It has 32-bit in one side, then a colon, and then 32-bit in another side. So this route distinguisher is a number that attaches to these routes and tells these routes that they belong to this routing table. So let's do this. I go to my configuration. First of all, I want to go to here, and you know that PC1 is going to talk to PC2. So let's go to console and start configuring. On console, I need to create a routing table. To create a routing table, I have two commands. One command is IPVRF, and then assign a name, or I can type a newer version of this command, VRF definition, and then type a name. It doesn't matter which one you are choosing. Both of them are doing the same thing, but VRF definition is the new format of IPVRF command. So I go for VRF definition and then type a name. The name doesn't matter. I just type a name. VRF, for example, 12, because I want router 1 and 2 to be in the same VRF. A VRF is a virtual routing, a forwarding. Actually, that's a routing table. So I hit enter. Now you can see that I am under VRF configuration mode. Now here, I need to specify a route distinguisher. As I told you, a route distinguisher is a number that attaches to a route. So I type RD and then check. You can see that it tells me there's a 32-bit number on the left side. It can be an AS number or it can be an IP address. It doesn't matter which one. And on the right side, again, there's another 32-bit number. This is a number in both formats. I just go for the number. And I type 12. 12, that's an easy route distinguisher to distinguish, okay? And I hit enter. The other command that I need to specify is a route target. A route target actually on VRF does not achieve anything, but I need to specify that, because if I do not, it tells me that there is a problem with your configuration. You need to tell what route goes to where. So let me show you. I want to go to my configuration here. Here I have a route distinguisher that tells the router to put this route in its correct VRF. Now, if I want to redistribute these routes, or if I want to advertise these routes to other routers, I need to tell them that there is a number attached to these routes, and based on that number, they can understand which routing protocol, which routing table these routes should go in. So, route distinguisher is local. Route target is, advertised to other routers. So a route target has the same format as a route distinguisher. They can be the same number, or you can use different numbers for route target. But because route target is not that important here, I just go and type route target. So route target has send and receive, and you can configure both of them at the same time. For send, you type export. For receive, you type import. Whenever I'm talking about MPLS, I'm going to talk about route target in detail. But here, I just want to go simple. Both means export and import. If you type both, it is going to execute a macro, and it is going to, type import and export for you. So I just type both, and this number, again, as I told you, can be the same as route distinguisher, or can be different. I just type 1212 to be easy to understand. That's it. Now I need to create another VRF. So this is going to be VRF34. Again, the route distinguisher is going to be some number. 32, 34 is good. And I need to have route target for export and import to be, for example, 34, 34. Again, it doesn't matter which numbers, but you can see show IP VRF. Now show VRF, I guess. You can see I have two VRFs here, VRF12 and VRF34. This is the default RDs. And now I need to go and assign interfaces to these VRFs. You need to assign interfaces to these VRFs, but before assigning, first of all, type this command, show IP interface brief, to remember what IP addresses you have on these interfaces. That's because when you are assigning an interface to a VRF, that interface is going to lose its IP address, and you need to reconfigure it. So if I go to interface fast 00 and type IP VRF forwarding, this is a command that assigns this interface to a VRF. The VRF is going to be VRF12 and hit enter. It tells me that cannot configure VRF forwarding since no address family configuration exists in this VRF-12. Actually, we have an address family here, and I'm not sure why we should have an address family on this, but let's go and type this VRF definition VRF-12 and type an address family here, and you can see that I have address family v4. Right now I'm using address family v4 and hit enter, and that's it. I do not need anything more than this. And for the other one, VRF-34, again I type address family IPv4. That's it. Interface fast 00, and again IP VRF forwarding VRF-12, and it tells me that use VRF forwarding command because this is a newer format. So I do not type IP VRF forwarding. Instead, I type VRF forwarding, and finally I need to hit enter. That's it. Interface fast 00 has lost its IP address. Now I need to type an IP address for that. 10.10.1.1, and this is why we should know about IP addresses, and I type this show IP interface brief command here. Now for interface fast 01, I need to again assign this to VRF-12. So I hit enter. Again, it loses its interface, and I need to type an IP address for that. 10.10.2.1. Interface fast 10 belongs to VRF-34, and again I need to type an IP address for that. 10.10.3.1. And finally, interface fast 11 belongs to VRF-34, and I need another IP address for that. Okay, now I have allocated these, so let me show IP routing table. In my routing table I have nothing because I have dragged all those routes from this and put them in another routing table. How can I see them? Let me see all VRFs at once. So I type VRF and an asterisk here, and you can see that I have, this is a global routing table, nothing in that. This is VRF-12 and this is VRF-34. So if you want to see only one of those VRFs, just type the name VRF-12 and VRF-34. They know about their own routes. That's it. So if I go to PC1 and try the ping again, the ping to 212 is successful. That's because they are in the same VRF. But the ping to PC4 is not reachable. Now if I go to computer 3 and try to ping 10.10.3.13, that's me of course. And if I try to ping 4.14, that's successful. But again, if I try to, for example, ping 1.12, that's not reachable. That's because this is in another VRF. So this is a very simple explanation of VRFLite. In next section, I want to start talking about MPLS, and in that, I'm going to examine a full topology.